Okay, welcome everyone. Thanks for joining. So let me tell you the plan. This is the week 3 webinar. And actually it might be the first webinar I've ever done at 6 o'clock on Tuesday because there were other things going on last night. And then we had the big climate talk at the college, which was really great. And I wanted to go to that. So there's all kinds of things going on. So we're having it at 6 o'clock, and it seems like that works for at least those who are here. And everyone else, of course, you watch on this YouTube. So let me tell you the plan today. As always, I'll do any Q&A. So any questions you have, and that could be throughout the whole webinar, just ask. If you put in the chat box, it's private, and I won't say your name. If you say it, they'll hear you, but that doesn't mean they'll know who you are. And but I'll answer any questions. And then after that, just going to give you a little quick review of what it means to be a discrete variable versus a continuous variable. We actually did that in the first week of class, but this is important for this week. Then we'll look at probability distribution tables. That turns out to be really important for chapter 4. And then we'll look at the expected value and the standard deviation given scenarios when you have a probability distribution table for a discrete distribution. Then we'll look at something called the binomial distribution, which is, again, about probabilities, but very different than last week. Then we'll look at continuous distributions. And then we'll get into the uniform distribution. So finally, we'll look at the mean and the standard deviation when you have a uniform distribution. So just a note, this week, we're doing both chapters 4 and 5. And most people, when the class is over, they tell me that if you combine all the work in chapter 4 and 5, it's still a lot less in chapter 3. So this is not a brutal week, even though we're doing 2 chapters. But this is actually the last week of doing 2 chapters. After that, we're going to do 1 chapter at a time. But hopefully, if you ever have questions, make sure you ask. If you don't ask, then I won't know to, answer them. And asking could be in posting on the Q&A board, could be coming to my office hours. It could be pop in your question right now in the chat box or whenever it is throughout this webinar. This is an odd week, so there's no exam this week. We're in week 3, so you don't have to worry about an exam. But I do want to let you know that I did grade your exams, submitted them yesterday, so you should have seen your scores. When you first do the exam and you look at your grade, it's always lower because it gives you zeros for the question I haven't graded yet, and then I usually grade it the next day, and then you get your full score. So again, I put in lots of comments. I put the comments on the Canvas comment sections for that particular assignment, and you can definitely see them. And please look at them so that you know what to do. So are there any questions at all about anything? Great time to ask. And I do want to remind you, you should have a partner if you don't have a partner yet for your project. And even right now, you can look in the chat box and, let someone be your partner or join a group or whatever it is. If there's 2 people that are looking for a partner. So make sure that you do that for the project one. Any questions? Don't see anything in the chat box. If not, then I'm going to move on. And just a reminder, do you remember the difference between a discrete and a continuous variable? Who remembers that? You can pop in the chat box on what the difference is. Yeah, kind of discrete is pretty much counted. Continuous is measured. That's a nice way of talking about it. So discrete is the idea is you can write all the answers in a list. Sometimes you need dot, dot, dot. There could be infinite number, but at least you can kind of list them, kind of talking about the order. And continuous is more like a piece of the real number line, all the numbers, including every possible decimal in between two numbers, for example. And so continuous, you could never even think about writing them as a list. Grammatically, so here's the somewhat formal definition. A discrete variable is a quantitative variable whose set of outcomes can be displayed as a list. Okay. Quantitative variables that are not discrete are continuous. Okay. So that's what today is all about. Chapter 4 and 5 are discrete distributions for 4, continuous distributions for 5. So that's why I'm reminding you about what these things are, because they're really important for this, this week. And I like to look at it as grammar. There's grammar that we learn, and most people don't even think about it. First time I remembered, or I thought about it, was actually when I taught English in Japan. And I had to explain how many versus how much, because if I remember right, they don't have that difference in their language, but we do. The answer to a how many typically is going to be discrete. The answer to a how much will typically be continuous. So things like, you know, how many hats do you own, right? That would be a discrete variable. Or how much do you weigh? And that would be a continuous variable if you do the exact weight. Any questions on that idea? Just a little review. Okay, so here's an example. And a car salesperson gives out a $10 gift to every customer who test drives a car. Okay, and I don't know, any of you sold cars before? Oops, I think I lost my share screen. Try again. Any of you sold cars before? Okay, I don't see anyone saying yes. Actually, my brother used to. And but some of you might have sold things where a lot of times you give a little gift to kind of get the person to come. You've kind of seen that before privately. Privately is a whole different thing. You wouldn't do the $10 gift kind of thing probably privately. But this is the kind of thing that happens, is that, you know, you give them a little gift to come, and then, you know, you hope that they buy something. Okay, not just for cars, but for lots of businesses. It's a big business thing. And I know some of you were interested in business. Okay, so 12% of all customers who test drive the car purchase the base model of the car, resulting in a $200 commission for the salesperson. 8% of all customers who test drive the car purchase the deluxe model of the car, resulting in a $300 commission for the salesperson. Okay, sounds pretty good, doesn't it? What do you think? Is that a good job in terms of making good money? What do you think? What's your guess? Any thoughts? Yes, no? Good job? Okay. So I see some yeses, I see some nos. And here's the deal. You may have no clue now, but you will have a good clue at when we're done with doing the statistics. Okay. And what we're going to do is we want to look at the profit. So we're going to look at the profit. Okay. Yes, you can go a whole month without selling a car, but there'll be some lucky days where you sell a whole bunch of them and you make super money. Do you see how that works? So, and we'll learn that. We'll see that how that works, and we'll actually see how long typically it's going to take whether you're going to have big lapses or not. And we'll see that with the statistics. So first thing I can say, by definition, the probability of anything happening is 1 That's for sure. What I'm going to do is I'm going to draw a probability distribution table. So here's what a probability distribution table is. It has two rows. Sometimes you'll often see it as two columns. It really doesn't matter whether you do rows or columns. On this one, I'm doing rows just because it fits on the paper better, or on the computer better. And we want to look at all the values of X. Those are the values of profit that could happen. Okay? What's the worst thing that could happen? We're talking about, one customer comes in. Yeah, you could lose $10. You give the customer a $10 gift. Customer test drives a car and says, oh, I hate this, I'm out of here. But they got their free gift, and you lose $10. So the X now is going to be negative 10 because it's a losing, so that's a negative dollar. Any questions on that so far? Okay, what's the next kind of thing that could happen that's not the very best, but in the middle one? What would X be? What would your profit be for the middle piece? Any thoughts? Not a trick question or anything, but there's a little bit of work to do, nothing too hard. Yeah, so that means that the person test drives a car, says, I really want the base model. They buy the car, you get a $200 commission, but you had to give the customer $10. So your profit is $10 less than 200 in this case. That'll be 190. Any questions on that? And what's the best thing that could happen for the car salesperson? What's the profit? What's the other thing that could happen in terms of the profit? You could be, sell the deluxe model. And what would the profit be if they sell the deluxe model? It'd be 290, exactly. Same idea. Okay, same idea is that there's a $300 commission, but they had to give the $10 gift. So that's a $290 of profit. Profit equals revenue minus cost. You might have heard that before. That's a standard formula for profit. All right, I'm going to go right to left just because it's a little easier in this case. What's the probability of getting this $290 profit? It's all in that question. You have one little tiny math thing to do. It's not hard. What's the probability of getting the $290 profit? Yeah, it's 0.08. Notice that we have 8%, but we need probabilities or decimals. They're not percents. So you need to take 8%, turn it into a decimal. So you need to move the decimal place over twice, and you get 0.08. What is the probability that the car salesperson will profit $190? Also not that hard. What is that probability? Hopefully all of you can figure that out because it's not tricky or anything. You do have to read the question. Okay, 0.08 was the probability of 290. That was the $300 commission. The 190 is the $200 commission. What's the probability of $200 commission happening? Because that's $190 profit. And what is that probability? It's in the question. Yeah, that's going to be the 12%, but we need to turn to a decimal, and that's 0.12. Any questions so far? Okay, the last thing we have to do is find the probability that the salesperson actually loses $10, has a negative $10 profit. And this is where I wrote total probability is 1. So that means that if we add all of the probabilities up, you have to get 1. So I'm just going to call the first one X, the one I'm interested in, plus 0.12 plus 0.08 equals 1. Any questions on that little bit of math right there? Any questions? That's a part of probability. If you add up all the probabilities of anything that could happen, you always get a 100% chance or a 1. Okay. It might help to add 0.12 and 0.08, and we get X plus 0.12 plus 0.08 is 0.2, 0.20. I'll write it that way. Equals 1. And then we need to subtract 0.2 from both sides. And what do you get? See if you guys can do that. You should be able to do it in your head, hopefully. Yeah, 0.8. Another way of looking at it is something plus 20% is 100%, and that's 80% or 0.8. And just to be consistent, I'll write 0.80. Just to kind of keep them all in 2 decimal places. Any questions at all on the probability distribution table? Any questions on that? Okay, this is actually, very, very useful for many, many things. As you can see, business is one of them. In the real world, a lot of times this 12% and 8%, you do that by, working for a couple months and seeing what happens. Do you see how that works? Okay. Any questions on that? Yeah, the 0.8 is not that if he doesn't sell the deluxe model, it's that if he doesn't sell any model, the base or deluxe. If he doesn't sell a car, then he loses $10. Do you see that? Because if he doesn't sell the deluxe, he can still sell the base, but that's where this 0.12 is. Is that clear? So that's the reason for that. Okay, so the whole point of this, if you're the car salesperson or doing any kind of business and a whole lot of other things that you do, is you want to see if this is a good deal or not, right? This is a good job. You're gonna make money, you're gonna lose money, how much money are you gonna make? Does that make sense? So what we're gonna do is we're gonna find something called the expected value. And we're also gonna find something called the standard deviation. Standard deviation you've heard before. Kind of the idea of the expected value is saying, well, let's suppose that, you take this job up, you're a car salesperson, maybe you work for 5 years, and this stays constant, kind of these probabilities and commissions stay fixed. Then you would say, well, if you work with, hundreds and hundreds and hundreds of customers, on average, how much money are you going to make or lose? Does that make sense? And that's what the expected value idea is. Any questions on the idea of the expected value? Okay. The standard deviation, on the other hand, we've seen that before. That tells you how much you fluctuate from the average up and down. And so if you're going to be having really good times and really bad times, then you're going to have a very large standard deviation. Whereas if most of the time you're about the same, you'll have the same standard. You'll have a close to 0 standard deviation. Any questions on that idea first? Okay, so the next thing we need to do is we need to calculate the expected value and standard deviation. Any guess how we're going to do that? Since we've now done it for a couple weeks? Or at least, yeah, we're going to go to the calculator. And let's see if you can tell me what calculator we need to go to. Which number? I tried to make it really obvious. I'm not here to trick you. Yeah, the expected value and standard deviation calculator, number 6. So I click on that one. Okay. And for reasons that have to do with the way like smartphones work, they tend to have more height than width. I made it columns instead of rows. So hopefully that makes sense to you. You see why I did that. That was one of the reasons why I decided to make it that way. And now we need to put our x's and our p of x's in. So again, our x's were negative 10, 190, 290. So I'm going to go negative 10, 190, and 290. And our probabilities were 0.8, 0.12, and 0.08. So I type those in. 0.80, 0.12, 0.08. Any questions on using this calculator so far? Okay, tried to make it easy. You do have to scroll down a bit. Note, by the way, if you had a whole lot of different choices, then this calculator won't work because you run out right about here. I think I remember how many this is, 10 or something. Yeah, 10. So if you had more, it turns out actually my spreadsheet has this to be able to do it, but that won't happen on any of your on the chapter assignments. So don't worry about that for the chapter assignments. But in the real world, sometimes it could happen. Okay. And then I just hit calculate. Okay, so my expected value is 38. Standard deviation is 98.4683. I'll just call it 98. Okay, maybe I'll do two decimal, 98.47. So 38. And the standard deviation, I think I put it here. Here we go. 38. The standard deviation was 98.46, I think. Let me double check. 4683, so 47. Any questions on that so far? By the way, any guess why I decided to take two decimal places? This wasn't just some random thing. Yeah, this is money. And in money, you usually do a whole number and you couple dollars, or you do two decimal and that's dollars and cents. So I decided to go for dollars and cents. So it's important to understand what's going on here. Okay. So in fact, I'm even going to put a dollar sign on these guys because those are the units for dollars for this particular example. Not every example is dollars, but this example is dollars. Any questions on this? Okay, so here's the interpretation. Okay, let me give you the template first. That is, if many trials are done, then it is very likely that the average of the trials will be very close to the expected value. Okay. You may notice I put many, likely, average, and close to in red. Any guess on why I did that? There's a reason. Yeah, they're important, and I will let you know something. So listen carefully, because here's what I'm going to say. I'm going to say this a lot in this class. If you don't have those words in your interpretation, when you have to write it out, say in the discussion post assignment or on the week 4 exam, I take off points. Got it? So if you don't want to lose points, you better have those words in there. Okay. The other words will change because you're not going to use the word trials or, the expected value. You'll have a number there, and we'll see that in a second. But these words have to be there. Many, likely, average, close to. So now we can interpret it. Maybe I'll make it a little bigger so you can see because it's so important. And that is if many customers come and test drive a car, then it is very likely that the average profit that the salesperson will make per customer will be very close to $38. Any questions at all on this idea? By the way, none of you said that you do this for a living. How long do you think it takes to test drive a car? Okay, an hour. Okay, so if it takes an hour, then you could look at it. Then on average, this is a $38 an hour job. Does that make sense? If it took 30 minutes, it would be actually a $76 an hour job. Can you relearn the many trial statement? Do you mean show it again here? Is that what you mean? The expected value template? Is that what you meant? Repeat. So if many trials are done, then it is very likely that the average of the trials will be very close to the expected value. Okay, and I do want to remind you, those of you who are watching this live, this is on YouTube. If you ever want to go back to it, you can always go back to it. You can also write it now. Take a picture of it, whatever it takes. Okay, and then the not general one, but the specific one is if many customers come and test drive a car, then it is very likely that the average profit the salesperson will make per customer will be very close to $38. Absolutely, it's mentioned in the chapter video. It's so important that that's a biggie. It's not exactly the same example in chapter video, but not that different. Okay. The standard deviation was 98.47. So here's the thing. If you make, on average $38 every time you get a car test drive, that's great, except the standard deviation is almost $100. And there'll be times at which you lose money, in fact. No, this has nothing to do with project one, by the way. Yeah, so you're asking if this verbiage is needed for project one? Absolutely not. You are not doing expected value in project one. Project one really is about chapters 1 and 2. Just to note. So don't even think about expected value. Yeah, you do a mean and a standard deviation, but that's not this kind of mean and standard deviation. You're not going to have a probability distribution table or anything like that. Okay. So this standard deviation is pretty high, which means there'll be days where you're not going to make any money. But there'll be days where you make great money. Okay. It's not in project 2 either, by the way. Just let you know that. But you don't want to forget it definitely by next week when you have to take the week 4 exam. And then it, review stuff is going to repeat on every exam. So you never want to lose it. No, you won't reuse this on the project. You will not use this on either project. Yeah. It turns out project 2, the main thing will be chapter 10. But we're not even going to talk about that now. Don't even think about project 2. Okay. Yeah, no, I said that you're going to use it on the week 4 exam. So if you heard me wrong, that's what I said. The week 4 exam is when you're going to have to get this, and also on the discussion post for this week. That's when you'll be using it. That's what I said. Okay. So the standard deviation is high, right? $100 when the expected value is only $38. That means there'll be times when you're not going to make any money. So if that's the case, what you want to make sure of is that you have some money in the bank so that you don't have bad days. And if you need to go to the market and you're hungry, then you better have some money, because you may not make money the day you need to, go to the market. Do you see how that works? So because you have a high standard deviation, that means you're going to have good days and bad days. So make sure that you have backup money in the bank so that, you can afford your basic needs when you lose money or don't make money. Does that make sense? Any questions on the idea of the standard deviation? Okay, so here's another example. I want to give you another example that's not an economics example. Still getting money involved, but it's very different. This is This is actuarial work. Do you know what actuarial work is? You heard that word before? Yeah, so on average, if you have the job, by the way, so back to the last example, and you work at that job for many, many, many weeks, then you're going to make money on average. Does that make sense? On the other hand, there'll be days where you don't make money. There'll be days when you make a lot more money, but on average, you're going to make an average of $38 per customer in the long run. And it's not going to be exactly 38, but if you have many customers, then you're very likely to make close to $38 per customer on average. Okay, you never actually will ever make $38 for a specific customer because that can't happen. That wasn't one of the X's. Do you see how that works? Okay, so here's the next example. Is you've been offered a life and dismemberment insurance policy that costs $1,000 per year. Just to make sure, because I know a lot of people have trouble with this word. Do you know what the word dismemberment means? There's an English word. It's not a math word. Yeah, that'd be like injury. That'd be like if your arm got chopped off and you don't die, but it's really bad for you. Does that make sense? Yeah, lose a limb is a typical one. Exactly. Exactly. Break your back. And then you're stuck lying in bed. You're not dead, but you need insurance for that because all of a sudden you can't work anymore. Do you see that? So they call this a life and dismemberment insurance policy. Let's say it costs $1,000 a year. And let's suppose the policy pays the heirs, okay, if you die, $100,000, right? If you die, you don't make any money. You don't get any money. But, if you have a child, your child needs the money and gets $100,000 or a spouse or whatever it might be. Okay. And $50,000 that you get in the event of dismemberment. Does that make sense? Any questions on that? There's a typical life insurance. There's a typical insurance policy that does this kind of stuff. Okay, the actuaries have determined that you have a 0.3% chance of dying this year. It's a very small chance. By the way, this is one of those where you do not want the big money to happen when you buy life insurance. Do you agree? Yeah, $100,000 goes into your heir's pocket, but then you're dead. But you still there's reasons to buy life insurance. And let's suppose you have a 0.3% chance of dying this year and a 0.5% chance of dismemberment this year. Okay? Any questions on that? Okay, find the expected value and standard deviation and interpret the expected value. Explain why the standard deviation might indicate that you still might be a good idea to purchase the insurance. Okay, so what is X? Again, we're looking at profit in this case. So what's one of the values of X that could happen? Yeah, negative 1,000. What's another value of X that could happen? So negative 1,000, that means you didn't make any money off of this life insurance. You just paid the 1,000. The year went on, nothing happened. Yeah, another thing that can happen is 49,000. That's dismemberment. Because that means that maybe your arm was chopped off. You didn't die. So, they're going to give you $50,000, but you paid 1,000. That's 49,000. What's the last thing that can happen? One more thing that can happen in terms of your profit or the profit. And what's the X value? What's the X value? Death it is, but what is the X value? Yeah, 99,000. Because that means that the heirs get 100,000. 100,000 was paid into the insurance company. So that's a profit of 99,000. What's the probability? Let's go to the 99,000. What's the probability of nine? What's the probability of 99,000? And the hint is it's not 0.3. Yeah, it's 0.003. Don't forget, you got to move the decimal over 2 places every time you see a percent. What's the probability of the 49,000? Yeah, that would be, what is it? 0.005, because move the decimal of 5% over twice and you get 2 extra zeros. Good, good. So it's always good to look at your answer and make sure it makes some sense. Okay. You do not want a 30% chance of dying, by the way. I hope none of us have anything close to that. Okay. How do I find the probability of negative 1,000? You have rule of complements. So you go 1 minus 0.005 minus 0.003. And by the way, 0.005 plus 0.003 is 0.008. 1 minus 0.008 is 0.992. Are you all okay with knowing how to put that in the calculator? Because I just said it. I did it in my head, but you're always allowed a calculator. By the way, if you buy the insurance, which do you want to happen? Negative 1,000, 49,000, or 99,000? Which do you want to happen? Do you want to lose $1,000? Do you want to make 99,000, or do you want to make 49,000? Which do you want? Okay. If you say you want to make the 99,000, you need to talk to a psychiatrist. That means you want to die. Okay, you want the negative 1,000. It's a weird question, but it's the truth. This is one of those you want to lose money. You don't want your arm chopped off. You don't want to die. It's better to lose money. This is one of those weird cases of that. So I wanted to kind of make sure you understood what this is all about. But you still want to look at, money. All right, so now, how are we going to find the expected value and the standard deviation? You hope that the highest value is not best for the heirs either, because you hope your heirs don't want you to die. If not, you might want to find some different heirs. Okay. You hope everybody wants the negative 1,000. Okay. How do we find the expected value and standard deviation? What do you think? Yeah, we go to the calculator. So one thing to do for the calculator, if you want to erase these, you could backspace all this. The easiest is to hit refresh on your computer. When you hit refresh on the computer, it erases everything. So just to let you know, that works on all calculators, by the way. So the x could be negative 1,000. It could be 49,000. Or it could be 99,000. The probabilities were 0.992, 0.005, and 0.003. So 0.992, 0.005, and 0.003. Any questions on that? We go ahead and we hit calculate. The expected value is negative $450. Standard deviation is $6,495.96. So we have negative 450. And our standard deviation was, let's look at it again, 6495.96. 6495.96. And I stuck the dollar sign because it's another example with dollars. Not all expected values are money, but these examples are. It's more fun. Okay, so what do you think? Is this a good buy? Okay, not if you care about the expected value. Okay, but of course it's going to be negative. Of course it's going to be negative because it's an insurance company. They need to make money. If it was positive, they would never sell it to you. Do you see that? That's how all insurance is. It always has to have a negative expected value. Is that clear? Okay. Now you could think about, if you buy this, if many people, that's probably what you want to look at. If many people buy this policy, so I'm going to say it instead of type it out, but if many people bought this insurance policy, then it is likely that on average, they will lose 450, close to $450 each. Any questions on that idea? Okay, so why an expected value is always negative for insurance? Why might you want to buy insurance anyway, even though expected value is negative? Any thoughts? And the hint is it has something to do with the standard deviation. Yeah, the standard deviation is really high. The standard deviation is really high. What that tells you is that there is a chance, it's a small chance, but there is a chance that something big will happen, which means you die or you lose a limb or something. And especially let's say you are supporting a family. Well, if you're supporting a family and you die, it could be a disaster for that family. So the standard deviation's high means that there's a very small chance of you dying, but if it does happen, there's a major thing that goes on. There's a big fluctuation in the money. Do you see that? On the other hand, if you don't have anyone that cares, that needs your money, and especially with this death part, it'd be stupid to buy insurance. Is that clear? Any questions on this example? Okay, let me tell you where I use the expected value. Any guesses? Where I personally use this expected value? It was a long time ago, but I used it and it was a big deal. Okay, so wouldn't you just put the money in savings so you don't lose the $40? Well, here's the problem. It's $1,000 that you're paying every year, right? If you die next year, you've put $1,000 in savings, and that is not enough to support whoever it is that needs it for that year. Does that make sense? Okay, so that's the reason. Yeah, so the way I use this was gambling. I know this is going to sound a little strange, but before I went to the casino, okay, because when I was young, I was, 21 years old. You can guess why I waited till I was 21 years old. I was a math major then. And I calculated the expected value based on card counting. Any guess on what the expected value was? and I'll do it by a percent. Any guess on what the expected value was? Yeah, you're right. The longer you have insurance, the worse it is. Okay, now the expected value is positive for me with my card counting technique. And the expected value is actually a 4% of the amount of money I spent. Okay, does that make sense? It was a positive 4%. Does that mean that I made money on every bet? Every time I bet? Does it mean I made money? Every time I played? One hand for each hand? Definitely not. Sometimes I'd lose, sometimes I'd win. But what I would do is I would go there and I would sit at the table for like several hours, like 4 or 5 hours. And if you make 4% on average, and every time you are betting an average of say $5, it's a lot of money you're making. Does that make sense? Actually, I bet $1. I'd say $2 or $3 on average, but $2 or $3 in those days was more like $20 or $30 now. There's been a lot of inflation since I was 21. So I never left the casino losing money. Okay. The game is not even a minute. Just give you an idea. So that means this expected value really works because if a game's not even a minute and you play for 4 hours, that's hundreds of games. Do you see how that works? So that's in that many. Yeah, that word many in the expected value was really important. So I played many games and I never lost in a 4-hour sitting. Okay. And eventually the mafia figured it out. Okay. I never left losing money. Okay. I almost left losing my life because they were going to kill me, but that's a different story. That's what they told me, at least. So I never came back after they told me that. So, but anyway, that's the kind of way you can make money. Okay. I can't do it here because, and you shouldn't either because they pay, at least I can't tell you which one. One of the casinos paid me to make sure the expected value was negative for card counters. I helped them change the rules. And I made money doing that too. And they didn't say they'd kill me because I helped them. Yep, it's rigged now. And it's partly my fault. And it's not against the law to rig it, don't change the rules. They just wanted to make sure card counters can't win. Okay, so now we're going to get to the next bit piece. We have more stuff to talk about. And that is binomial distribution. So binomial distribution, okay, it comes from multiple independent trials of a yes-no question and measures the number of yes answers. So that's the definition. It really helps to see examples to truly understand what this definition is. So lots and lots. Let me give you some examples and then I'll show you my kind of favorite, kind of somewhat depressing example. But so an example is if you're doing a survey and what's the big thing that happened in the news today? Anyone know? Anyone know the big thing that happened in the news today? It might have been terrible for you. It might have been good for you, depending on how you feel. Maybe you don't care. Anyone know? Okay. There was Trump related. It was a primary election in, I forget which state, but one of the states. It was a main one because it was either you voted for Trump. Yeah, New Hampshire. Yeah. I think Iowa was the one last week and New Hampshire was this week. Had to go remember which was which. And either you voted for Trump, okay, if you're a Republican, either you voted for Trump or you voted for Haley. Because if you remember, DeSantis stepped down. And those were the choices. By the way, if you're a Democrat, we can look at it. Either you wrote Biden in as a write-in or you didn't write in Biden. That sounds weird. I'm not even getting the details of that. It's not statistics, it's politics. But if you're a Democrat, those were your choices pretty much, is you wrote in Biden or you didn't. And, and pretty much if one person comes in and votes, the next person behind, some other person doesn't look at that person's vote. So that would be independent. Does that make sense? Any questions on that idea? Okay, and it's a yes, no. So here's another example. It's a bit depressing, but it's really important. I don't know, any of you in Tahoe right now? Okay, we got a few Tahoe. Did any of you go to today's big thing at the college? I went, by the way. Okay, the head of I forget what the agency is called, but it was, you're here and didn't go. Too bad, because she was really good. And the head of the agency talked about climate change. Okay, and gave a really amazing presentation. So let me show you, this is real, by the way. There have been 142 years in recorded history of global temperatures. Okay. Okay, so before that, we just didn't have a way of recording it. In the next 20 years, if the weather is random, find the probability at least 10 of them will be in the top 10 of the prior 142 years. Any questions on the question? Okay, so by the way, each year either is in the top 10 or is not in the top 10. Do you see why that's a yes, no? Any questions on that? Okay, so each year is either in the top 10 or not in the top 10. We're assuming, this is a big assumption. By the way, what's the first three letters of the word assume? Here's a hint. If there are children around, I can't say it. But actually, when I post on YouTube, I say this is not for children. Okay. You don't know the first three letters of the word assume? Okay, I'll tell you ass. And it's ass out of you and me, because UME. So be careful about assuming anything. And we're going to see why assuming is is just wrong here. So instead, let's find out. And we're going to see why that might be a bad thing to assume that it's random. All right, so this is an example of binomial distribution. Okay, because we're assuming randomness. Okay, and it's yes, no question for each. N is going to be the number that we're surveying. How many are we surveying? And there's a lot of numbers here, so this might be hard for you. How many are we surveying? The hint is it's one of the numbers there. Yeah, we're surveying 20 because what we're saying is in the next 20 years. So we're looking at these 20 years that are coming up. We want to find this probability. So N is 20. Any questions on reading this question and seeing that N is 20? What's the probability of a yes? What's the probability of being in the top 10 of the prior 142 years? This is not supposed to be that hard. There's no fancy math to do or anything. So what's the probability of being in the top 10 of the last 142 years for any particular year you're going to look at? Yeah, 10 divided by 142. Because there's 142 years you're looking at, 10 of those are in the top 10. Do you see how that works? Okay. We want the probability that at least 10 of them are in the top 10. So we want the probability that X is greater than or equal to 10. Any questions on that? All right, I want to show you something. We're going to go back to the calculator. We're going to do a calculation, and don't even think about doing this by hand. Which calculator do you think I'm going to use? What number? Which calculator is the right calculator? Look. Yeah, there's number 7, because we looked and we checked that this is a binomial distribution. So I'm going to click on number 7, and you will notice in a moment. Have a long moment, sorry. There we go. It asks for the low, the high, trials, and P. And what it says is enter the lower bound, the upper bound, the number of trials, and the probability of success, and then hit calculate. So what's the lower bound? What's the lowest number that's less than or equal to 10? Hint is it's really easy. What's the lowest number less than or equal to 10? Sorry, greater than or equal to 10. What's the lowest number greater than or equal to 10? What's the lowest number greater than or equal to 10? 10. Okay, 10 is the lowest number greater than or equal to 10. So that's the low. Actually, maybe I'll put it here first. Low is 10. What's the highest number greater than or equal to 10 that can happen? 20, because we're looking at 20 years. Now you can't, if we're only looking at 20 years, you can't have infinity of them being in the top 10. You can only have 20 of them being in the top 10. You see how that works? Does that make sense? Why it's not infinity in this case? Because we're only looking at 20 years, and the highest number of those 20 years that can be in the top 10 is all 20 of them. How many trials? The hint is we already did it. What is it? 20. That's n. And p equals? And this one, we already did it, but it's fractions aren't good. You have to use decimal. 10 over 142. So I'm going to go to the scientific calculator. I'm going to type 10 divided by 142. And it's this messy number, 0.0704, etc. Any questions on those? So we have 10, the high was 20, number of trials was 20, and P was this 0.07042, etc. I copied and pasted so I didn't have to spend time. Any questions on getting the information into the calculator so I can hit calculate? What does it say, by the way? What is the answer really 0, by the way? What do you think? Do you think the answer is really 0? Yeah, it's not 0, but it's so close to 0 that it rounds to 0. So maybe to the nearest trillionth. Yeah, exactly. So it is incredibly close to 0. So that means we have almost no probability. When you have almost no probability of something happening, and it happens, what do you do at that point? And this is what this class is all about, by the way. Okay. Doesn't mean statistics has failed us. What it means is we were assuming something was wrong. Right here, weather is random. We're assuming that next year has just a high probability as any other year of being in the top top 10. Why is it not random, by the way? And this is not math, this is science. Why is next year does not have the same chance of being in the top 10? Yeah, climate change. So this is where the scientists come in. So this is how statisticians and scientists work together. The statisticians say, hey, this probability is so small, something's wrong. It's not random. We're not the same as it has been in the last 142 years. Yeah, things are different on Earth right now. And that's how scientists and statisticians collaborate and come up with convincing arguments, scientific arguments that we have climate change. Any questions on that? Okay, and then the scientists go and say, well, what could be making it warmer than it should be? Do you see how that works? And by the way, do you know, by the way, in terms of 2023, in recorded history, do you know what 2023 ranked is in terms of global temperature? The hint is it wasn't just in the top 10, it was more special than that. Anyone know? It was the hottest year ever, okay, in recorded history. Okay. So that's how science works. And then you realize when you have such a small probability, this randomness, it means something is going on. And then you find out what could cause it to go on. And you look at all the things on Earth in the last, 20 years or so that has changed since 142 years ago. And there's only one thing that's changed. And that's carbon dioxide, it's the atmosphere. Any questions on that? So that's how science works. That's why this is it's oppressing because unfortunately we're in climate change, but statistically it is so clear. Okay, let's do another example. Okay, this is maybe depressing. Sorry if it's a depressing day, but 38% of Americans say they feel exhaustion over the prospect of a rematch between Biden and Trump. Okay. And again, I'm trying to use the news, what's going on recently. And again, I went to this climate change talk today. Today was the big election. And unfortunately, it's pretty high percent. Don't even like either of them, basically. They're like, nah. Okay. If 15 randomly selected Californians are surveyed, okay. How do I get Americans? Surprised Google didn't say it's wrong. Americans. That's better. If 15 randomly selected Californians are surveyed, what's the probability that between 5 and 10 of them feel exhaustion? So what's the low? Notice there's a yes or no. Do you feel exhaustion about Biden versus Trump? What's the low? Yeah, 5. What's the high? 10. How many trials? Not 10, 15. Because it says that 15 randomly selected Californians. So we have 15 people we're asking. And what's P? Yeah, 0.38. So it's really easy. Let's go to the calculator. I'm going to refresh. Clears everything out. Unfortunately, my internet's slow, I think because I'm on Zoom too. And again, go to low, 5, 10, 15.38. So we go 5, 10, 15, 0.38. Any questions on that? And I hit calculate. Okay. 0.7272, or about 73% chance. Any questions on that example? Okay, what's the probability that at least 6 of them feel exhaustion? Okay, and sometimes the hardest part is taking words like at least and really understanding what they mean. If you have at least 6, what is the lowest number that's at least 6? 6. What's the highest number that's at least 6 in this experiment? Not 6. 15, because we're asking 15 people. Number of trials is still 15, and P is still 0.38. 3/8. So now we're going 6 to 15. So the low now is 6. The high is 15. Same trials in P. Okay, calculate, and it's about 53%. Any questions on that example? Okay. How about fewer than 6 of them feel exhaustion? What's the lowest number that could be fewer than 6? 0. Exactly. What's the highest number fewer than 6? Not 0. Not 1. Notice 2 is fewer than 6. That could have happened. 5. 5 is the highest number that could have happened that is fewer than 6. One of the hardest parts about this binomial stuff is to come up with the low and the high based on the wording. Number of trials is the same. I don't want to spend all the time, but I just want to make sure we can do the hard part. How about exactly 5 feel exhaustion? What's the lowest number that's exactly 5? 5. What's the highest number that's exactly 5? Also 5. So that'll be 5 to 5. Okay, so it's, again, really important to get the wording right, read the wording, and turn it into a low and a high. And that takes practice. So I've done some for you, but you'll get to do more on the exams. I mean, on the exercises. All right, let's go to chapter 5. Chapter 5 takes a little less time because there's really only one main topic. So if you have a continuous distribution, that means you can't list all the items. And notice, by the way, in chapter 4, we had discrete distributions. We could make a table. When you have a continuous distribution, you cannot make a table of all the outcomes. It's not possible. So instead, you usually draw a picture. Okay. By the way, this is really important. What's the shape of this distribution here? In one word. And statistics word. Yeah, Bell is the old word, but the word we're going to use in our class is normal. So we did get one person to get it right. This is a normal distribution. Okay, and it's very important that you get that word, get that down, to be able to look at that and say it's a normal distribution. Okay, it turns out that if we want the probability of, say, between 1.8 and 2.75, that would be the area under the curve between those two numbers. All right, some bad news and good news. The bad news is to find the area under this curve is a normal curve. Any guess on what you have to do? If you really want to do it by yourself. Yeah, you need to take a full year of calculus By the way, 1/4 would not be enough. 2/4 would not be enough. You would need a full year of calculus. And even after that, you'd be crying. It is brutal. Okay? Here's the good news. If something's that hard for this class, what does that mean you're going to have to do? Why it's so complicated? You need to take calculus to know. I can't even go there. Yeah, the good news is when we get to the normal distribution, you're just going to let the calculator do it for you and just trust it. Trust that I did it right. Got it? I did use calculus, by the way. Okay. Yeah, I'm not even going to go there. So just trust it. But there is actually one shape that I do expect all of you to find the area of. What is the easiest shape to find an area of? In one word. Yeah, I'm going to say rectangle. You're right, square, but I'm going to go a little more broad and say rectangle. And hopefully you'll all remember from elementary school. How do you find the area of a rectangle? Yeah, base times height. So you're going to use that formula a lot in chapter 5, by the way, base times height. Okay, so the uniform distribution, it's a distribution, here's a formal definition, such that any two given intervals of length k that's contained in A and B has the same probability of occurring, and any interval outside of AB has a 0 probability. Okay? But a much easier way of understanding it is the picture of the distribution is a rectangle. Isn't that easier? Okay, this is something important. We're going to use the symbol x for the variable. Who knows what this symbol is? Everyone who speaks Spanish has seen it. Or who reads Spanish at least. Yeah, this is actually, wow, usually I don't know people, usually people don't know how to say it. It's called the tilde. Okay. Yeah, you actually did spell it right, T-I-L-D-E, but I'm not going to ask you to spell it because it's on a keyboard, so you can always type it. Does that make sense? Every keyboard has it. It's shift and next to the 1 is the tilde, by the way. And then U, what do you think U stands for? Very important. Here's a hint, it's in red. Uniform. And then A is the lower bound and B is the upper bound of the rectangle. Got it? Okay, it turns out uniform doesn't happen that often, but it's the only easy one. So it's the only one you can do when you're first learning it. So that's why we're doing uniform. Okay, it turns out normal is what happens most often. We're going to do that next week, by the way, but that I can't even go to the geometry with you guys. It's too hard. Okay, so here's an example. So suppose that the time that students spend with a math tutor is uniformly distributed between 10 and 120 minutes. By the way, do you remember what it means if I have the word suppose? So I want to give you all a heads up. Remember what it means if I say suppose? Yeah, it means I totally made this up. Do not quote me as this is a fact. But I wanted to give an example that's easy to understand. Okay, so suppose it's uniformly distributed. Probably not, but let's just suppose it is. And between 10 and 120 minutes of time. Okay, so the first thing in symbols, we write x tilde u, 10, comma 120. Okay, there's a good chance on the exam you're going to maybe have to do that. So make sure you know how to type this. Okay, not hard to type. If a randomly selected student who uses a math tutor is observed, find the probability the student will spend between 30 and 70 minutes with the tutor. Any questions on the question? Okay, so here's what you have to do. The first thing you do is you draw a picture. And the picture, because it's uniform, because I said it's uniformly distributed, is a rectangle. And the low is 10 and the high is 120. So that means the left side of the rectangle is 10. The right-hand side of the rectangle is 120. Any questions on that? The height of the rectangle, we don't know yet, but we're going to be able to find it out. Any questions so far? Okay, so we're going to use something really important to find this height. What's the probability that a randomly selected student will spend between 10 and 120 minutes with the tutor? The hint is it's really easy. Yeah, it's 1, because you can't spend less than 10, you can't spend more than 120, so there's a 100% chance of spending between the lowest and the highest. So I could say that the area of this whole rectangle is the base times the height, and that's equal to 1. What's the base of this rectangle? How do I find the base of this rectangle? Looking at this picture. It goes from 10 to 120. Yeah, I take 120 and I subtract 10, and that's how you find the base. And the height, we don't know. I'm going to call it h. So that's equal to 120 minus 10. You probably don't need a calculator. What's 120 minus 10? What is it? Not a trick question. It's supposed to be easy. Yeah, it's 110. So if 110 times h is equal to 1, and I want to find h, what do I do to find h? Now it's basic algebra. We do a little bit of basic algebra in this class, and that's it. And this chapter has a little bit. There's a little more we're going to do later today. And not much later, because we only have like 15 minutes left. Any questions? How do we find h? Yeah, we divide both sides by 110 to get rid of the 110 on the right. And we get h is equal to 1 over 110. Anyone lost on what just happened? That's the first step. Okay, now that we found h, we know what h is. Now we can think about finding the probability that the student spends between 30 and 70 minutes. So I can draw this picture again, which is what I just did. And now I have between 30 and 70. And now the probability of being between 30 and 70 is the base times the height. The base is what? Of this between 30 and 70 rectangle. How do I find the base? Good, I go 70 minus 30. And the height we found already, that was 1 over 110. And by the way, 70 minus 30 is 40. You get 40 over 110. Or if you want, 4/11ths. Okay. By the way, when you're doing the assignments and the exam, read the instructions. If it says write as a fraction, write as a fraction. If it says write as a decimal to 4 decimal places, put in the calculator and get, 4 decimal places. Any questions on this example? Okay, let's do another example. Let's find the first quartile, Q1, for the time that students spend with the math tutor. Do you remember what it means to say Q1 or first quartile? What does that mean? So what's it mean to even say first quartile? This happened a couple weeks ago. Half median. It's not usually how people say it, though. Yeah, 25th percentile, or the probability of being below that value is 0.25. Any questions on that? So now I'm going to draw a picture, and this is really important to understand the picture. So I draw my rectangle. It goes between 10 and 120. My h, by the way, we already know is 1 over 110. But the 0.25 is not down on the x values. That is a probability. It's the area of this rectangle. What I don't know is x. I don't know how far to the right I need to go. And when you don't know something, that's when you usually call it x. So I want to stop and make sure, are there any questions on the picture? Because you need to know how to get this picture kind of thing down. Are there any questions? Okay, now that we have this picture, then we can start using the area is the base times the height. What's x? So x is the first quartile. It is the value of x that gives you the first quartile, so that 25% is below that value. Does that make sense? That's what x is. It is the first quartile. The first quartile is an x value. You could call it Q1 if you want, but since we're going to do a little algebra, I'm going to call it x for now. That help a little bit? Okay, so now what we can do is now we can do some algebra. So the probability of being between 10 and x is 0.25. Probability is base times height. The base now, just like we did before, we subtracted the high minus the low. The high was x, the low is 10. So the base is x minus 10. Any questions on that? The height was 1 over 110. That hasn't changed. Now we have some algebra. So we have 0.25 equals x minus 10 over 110. So now we have to do some algebra. I like to think of it this way. You start with x, subtract 10, then you divide by 110. When you want to solve for x, you do it in reverse. So the last thing I said was divide by 110. How do you undo divide by 110? How do you get rid of the over 110? Yeah, we multiply both sides by 110. When you do that, the x minus 10 comes by itself because the 1 over 110 goes away. And we could say x minus 10 is equal to 0.25. And then I got to multiply by 110. And I wrote it in the other order because it'll be nicer to have x on the left. Okay, then how do you undo the minus 10? How do you get rid of a minus 10? You add 10. If you add 10 to x minus 10, you get x. So then I have 0.25 times 110 plus 10. And when I do that, I get 37.5 when I put it in my calculator. So that was a little algebra. One thing I strongly recommend is go back to the picture and see if that seems reasonable. Does x equals 37.5 look about right for being in the first quartile? Looks okay, doesn't it? If you got x equals 130, worry. That cannot be the first quartile because that's like way over here. Do you see that? So you want to make sure it's kind of where you kind of guessed and placed it. Any questions on that example? Okay, I'm not going to do all of these. I'm going to do, let's see. I think I'm going to skip, and we need to get to the next section because I don't want to. I try to finish before 7:40 every time, in the evening ones. Okay, so here is a big theorem. The first part is going to make total sense, and the second is going to be totally like why. And that is if x, yeah, so now you know the x minus a. Okay, if X is uniformly distributed between A and B, then the mean is A plus B over 2. That should make total sense. That's just the average, isn't it? Right? Doesn't it make sense that in this example, for example, if you wanted the mean for this rectangle, you'd add 10 plus 120 and divide by 2? Doesn't that seem how you get to the middle there? Do you agree that that makes total sense? Okay, now you still might want to write it in your notes, so that you have it. The standard deviation is the square root of b minus a quantity squared over 12. Okay, I would be shocked if any of you were thinking that that would be the standard deviation. I will tell you the reasoning behind it, we will not do in this class. In one word, what do you think you have to know to come up with this? Any guess? The hint is we're not doing it in this class. Calculus, okay? And y12, you need to take 2/4 of calculus actually for that one. So you need to take 2/4 of calculus and then you'll learn y12. But there's no way in the world I can explain it to you. So what you do need to do is write it down, and it's in the book too. So you have these down. All right, so now I have an example. This is our last example to go through. Okay, suppose that the number of ounces of water that people drink from a drinking fountain is uniformly distributed between 1 and 8 ounces. Okay, and again, if I ever say suppose, that means I, pretty much made it up, but it's a good example. And the number of ounces of water that students use to fill their bottles. There's a big difference between going to a drinking fountain and, drinking versus filling the water bottle, which I have here, because I'm not gonna drink this whole bottle. I'm gonna drink a little of it, put it away, and that's enough for me for now. Does that make sense? So those number of ounces is going to be between 4 and 16 ounces. Okay? 4 because it might be the small bottle, or maybe it's already half full, so they don't have to put much in. Okay? Let's suppose you watch Thorn take a 2.5 ounce drink out of the drinking fountain, and Preston fill his water bottle with 5 ounces of water before he runs off to class. And by the way, just for fun, these were 2 of my students. They had cool names, so I used Thorn and Preston. Okay, whose water usage is more unusually small compared to the rest of the people who use the fountain for the corresponding water usage? Any questions on the question? Okay, now from chapter 2, how do we determine how unusually small something is? Z-score, exactly. So what we need to do is we need to find the Z-score for the drinking out of the fountain and the pouring the water bottle. Any questions on that idea? Okay, to find a Z-score, what things do we need? What numbers do we need to find a Z-score? It was in the formula for Z-score. What do we need? Yeah, we need the mean. And what else do we need? We need the standard deviation. And we need one more thing, actually. We need the value of X. So we need 3 things. So to find the Z-score, we're going to use X minus mu over sigma. We need X, we need mu, and we need sigma. Okay, so for Thorn drank 2.5 ounces. That's Thorn's X. Does that make sense? Now comes the hard part. The mean for Thorn, again, if you look, drank out of the drinking fountain. And for the drinking fountain, it's between 1 and 8 for a uniform distribution. So for the mean, we take 1 plus 8 and we divide by 2. Maybe I'm going to make this bigger so you can see it better. Any questions on finding the mean? 1 plus 8 is 9. 9 divided by 2 is 4.5. For the standard deviation, we have to use the formula. That was this messy thing, square root of b minus a squared over 12. That's square root of 8 minus 1 quantity squared over 12. And this is where you got to put it in your calculator. And this is just, stick it in the calculator. And I got about 2.02. Any questions so far? So the z-score for Thorne was x, which is 2.5, minus mu, which was 4.5, divided by the standard deviation, which is 2.02. I put that in my calculator, and I got just around -1. So at least a couple decimal places. Any questions on that? By the way, was Thorne's drink an outlier or not? Was Thorne's drink an outlier? Yeah, no. Outliers are farther than 2 from the mean. So the z-score would have to be like -2.1 or something. Okay? And so if it's between -2 and 2, which -1 is, it's not an outlier. Got it? Okay. Preston, on the other hand, filled his water bottle with 5 ounces. So for Preston, X was 5. Now for the water bottle, we can see that it was uniformly distributed between 4 and 16 ounces. So for Preston's mean, I'm going to take 4 plus 16, divide that by 2. 4 plus 16 is 20. Hopefully you can do 20 divided by 2 without a calculator. That's 10. The standard deviation is the square root of 16 minus 4 quantity squared over 12. That was the formula. And I put that in my calculator. You don't want to do that one in your head. And I got 3.46 for the standard deviation. Any questions on that? Okay, now the z-score will be x, which is 5, minus mu, which is 10, divided by the standard deviation, which is 3.46. I put that in my calculator, and I got -1.45. Which was more unusual? Thorne or Preston? Yeah, Preston was more unusual because Preston's z is farther from 0. Any questions on that? Was Preston an outlier? No, not an outlier. More unusual than Thorne, but not an outlier. Do you see how that works? Any questions on this use of these big formulas for the mean and standard deviation for the uniform distribution? Any questions on that? Okay, so it's 4:35, 7:35. So secret word time. The secret word is close. Any guess on why it's close? Why did I put that as a secret word? Yeah, that was one of the words I said you had to use for the expected value. So close is a secret word for this particular webinar. So notice today we went through a lot of details. Okay, like a whole lot more than the probability lecture, but the good news is just about every problem looks very similar to one of the examples I gave. There aren't a whole bunch of other types of examples that you have to deal with. Most of them are going to be very similar to something I did today. So make sure you paid attention to every example I did. And then when you get to the chapter 4 and chapter 5 assignments, just find the example I did that's real similar to the question you have to do. And, you'll change the numbers, of course, but other than that, it'll be real similar. Does that make sense? Most people don't complain about these 2 chapters, but so many complain about chapter 3 because those don't look all the same. Okay, I think I'm going to, again, it's 7:36, so about around what I would like to do. So I am going to, most people say chapter 3 is the hardest chapter of the entire book. Okay, not everyone, but most people. So I'm gonna stop the recording, and remember there's no exam, but there is a discussion post and there's 2 chapters you have to do. So let me stop the